So before we even do anything, let's just play around with actual graphs. If you don't want to do on your graphing calculator, just watch up here, you can. Let's start with a degree of 1. It's a linear graph. We're all familiar with a degree of 1 graph, right? Yep. It's a straight line, it's diagonal. If I were to add a plus 1 after that x, what would happen to my graph? It would move. It would shift where? Up. How many units? 1. Right, because your y-intercept would change. If I were to change it to a minus 2, what would happen to my graph? It would go down 2. Good. If I changed my degree from an exponent of 1 to an exponent of 2, what's going to happen to my graph? It's going to be a parabola, right? Is my parabola facing up or down? It's facing up. What if I put a negative in front of it? It's going to make it go down. What if I put a plus 1 after it? It's going to move. It's going to shift up 1. If I went plus 5, it would shift up 5. If I made it minus 5, it would go down 5. If I put a negative in front of this, it would just reflect it and make it go upside down, right? How would I move the parabola left or right? We've got the up and down, down. If I put a 2 in front of the x, what happens to my graph? It's making it skinnier, right? More narrow. Yeah, if I move this exponent of 2 outside, and now make it squared. Where's my squared? There, I just shifted it. So now shift it over 2, shift it over 5. How would I make it move to the left? Make it a plus 5. Good. How would I shift it to the left 3, down 1?
Then you put in minus 1 outside.
So plus 3, and then shifting it down 1, put a minus 1. We shift it that way, right? If I wanted to shift it to the right 4, up 5, what would that look like? Minus 4, and then a plus 5. Good. So now I shifted it to the right 4, plus 5. All right, so we know what a parabola looks like. What about a cubic polynomial? What does that look like? It's kind of like that squiggly S, right? If I put a negative in front of it, what happens? It goes opposite directions. Good. If I were to put a plus 5, what happened? It shifted up 5. If I made it a minus 5, it would go down 5. How would I move it left and right? Put it in the parentheses again. So plus 5 to the 3rd power. Shifted it to the left 5. If I make this a minus 5, what's going to happen? It's going to go to the right 5. If I added a plus 2 at the end, what would happen? It would go up 2 spaces. I made it minus 2. It would go down 2. What about a degree of 4? What does that look like? So it looks, right now, it's looking pretty much like a quadratic, right? But what's the difference between that and the quadratic, the blue and the green? Yeah, the blue seems a little bit flatter at the bottom, right, than the green. So every time I keep going with an even degree, so there's power 6 is the purple. Notice that's even more flat than the blue one. If I went with a degree of 8, what's happening? Going to happen?
Super flat.
Yeah, it's getting more flat as we go. Okay, but it still has the same left and right behavior, right? They're both going up on the left and they're both going up on the right. Do we see that? If I put negatives in front of all of these, what would happen to all of them? They're all just going to flip and go upside down. Good. All right, well, let's go to odd exponents. So here was our 3. Yeah, let's change this to a 5. Let's change this to a 7.
So that has also the flat component.
Get rid of the negatives.
Keep it really flat.
Yeah, so things are flattening out the higher that our degree gets, right?
Yep.
So we started off with the blue, that was our cubic. Then we had our 5th degree, the quintic. Then our degree of 7, and then our degree of 9. Right now, all of the graphs, what are they doing on the left side? Are they going up or going down? They're going down. And on the right side of the graph, they're going up. If I were to put negatives in front of all of these, what's happening to the end behavior? They're all switching. Good. Okay? So, these are some things that we should be able to pull right from our head. If I have an odd degree, I should kind of have an idea of what the graph should look like if I were to just make a quick sketch. So if I see an odd degree, I should know it's probably going to look something like this, or it's probably going to look something like this. If I have an even degree, it's probably going to look something like this, or something like this, depending on what makes the change between these two.
Negative or positive?
Right, negative or positive what?
Coefficient.
Leading coefficient,
Yeah.
right? That A, whatever's in front. Okay, so here we go. Really quickly, let's make quick sketches on our, now these are just going to be sketches. Don't make them beautiful on your notes. So if I had an x to the 3rd graph, just making a quick sketch of what that would look like. What would it look like? Where would be the turning point, if we want to call it that?
0.
It would be at 0, 0, right? Let's quickly just do mental math. If I plug in 1 for my x here, what do I get for my output? 1 to the 3rd power is 1, right? If I plug in -1, what do I get for output? -1. Good. So my cubic graph would look something like that. So I'm just going to put here f of x is equal to x to the 3rd. Now I can do it in a different color. You might not be able to do that. What would happen to that graph for x to the 5th?
It would become linear.
Would my points change? Would 0, 0, 1, 1, and -1, -1 change? Because if I take 1 to the 5th, it still stays 1. If I take -1 to the 5th, it still stays -1. But what happens? What do we say happens when we make that degree? It's going to flatten out a little bit more. So I'm just going to flatten it a little bit more on that inside part. And that would be my f of x is equal to x to the 5th. Okay? So you should be able to think in your head, if I have an odd degree, what that graph should look like. Because my leading coefficients were positive, I know that my left behavior is pointing down, my right behavior is going to be pointing up. If I put negatives in front of those, what would happen?
It would flip.
Yeah, so then it would turn into something like that, right? If I put a negative in front of it. Huh? Nice thick line. All right, so let's do an even degree one. Let's change it to 4 and 6. Again, we're just making a quick sketch of this, so you don't have to make it beautiful. X to the 4th. If I plug in 0, what do we get? 0. If I plug in 1, what do we get? 1. If I plug in -1, what do we get? Careful, it's going to be 1, right? -1 4 times would be a positive 1. So we get something that looks like a parabola, but let's flatten it out a little bit more than a parabola. So there's my f of x is equal to x to the 4th. What would change for my x to the 6th? It's going to flatten even more. Are my dots going to change? Are my points? Nope. So we're just going to really flatten it out. So f of x is equal to x to the 6th. All right. So we've got the pattern of our two shapes. What would happen if I put negatives in front of both of those? They would go upside down. Good. All right, so let's make a quick chart to just talk about what end behavior actually looks like for our graphs. So let's make a quick table here. I want you to put the degree. Let's make a column for leading coefficient. If I just put LC, will you guys all know what that means?
Yeah.
So LC, leading coefficient. And then we're going to put what's happening on the left. And then we're going to put what's happening on the right. I'll make a quick example at the end. All right, so if my degree, let's start with our evens, because that's kind of the easiest one to remember. If my degree is even, so 2, 4, 6, 8, probably won't get any higher than 6. 8's kind of getting crazy. If I have an even degree and my leading coefficient is positive, what does that graph look like?
A parabola facing up.
A parabola facing up. So let's put that over in the example first. So it's going to look something like that. So what's the behavior occurring on the left side of the graph? Is it going up or going down? It's going up. And we're going to call that a rise. So it is rising as our graph moves to the left. Does that make sense? So as my graph is going left, we are rising. What's happening on the right? It's also rising. Good. If we had an even negative, what would change?
It would be facing down.
It would be facing down. So we're going to call that falling on both sides. Okay. All right. What about odd positive? What does that look like?
The S shape.
Yes. Let's make the diagram first. So there's our diagram first. What's happening on the left? Is it rising or falling? It's falling. On the right? Good. And then if we had an odd negative, what's going to happen? Yeah, so it's going to just reverse. So it would be a rise and then a fall. Oops, that looks really bad. Hopefully yours looks better than mine. So something like that. Okay. Got that so far? Okay, good. So now, what we call these specific points has a specific name, and it's called an actual turning point. And there's actually a theorem that lets us know what the maximum number of turning points that we possibly can have. Has everybody got this?
Yeah.
Okay, so this talks about our end behavior. Bypass all that stuff. So for a turning point, this is your most important part of what you're going to get out of this. So a polynomial function of n degree has at most n minus 1 turning points. So if you're asked to determine the maximum number of turning points that a polynomial function can have, you take your highest degree and you subtract 1 from it. So if we had a cubic, the maximum number of turning points we could have would be 2. If I had a quadratic, the maximum number of turning points I would have would be 1. If I had a quintic, so degree of 5, the max number of turning points that we could have would be 4. Okay. So when we talk turning points, like right now on these basic graphs, this cubic only has 1 turning point. It's turning right here. It's turning right here. This quadratic only has 1 turning point. So if we talk about a turning point, it's kind of where something is changing. It's going from a rise to a fall, or it's going from a fall to a rise, or it's going from a fall to a fall. So something is changing in the behavior of the graph. Okay? All right, because I think there's a few questions. There's 2 questions on your homework that just asks how many turning points are going to be on the graph, and that's all you're going to do. Determine the maximum number of turning points of each graph. All right, you ready to do some graphing? Let's do some real graphing now. Here we go. Skip this. We went through all that. Ignore that. That's what we did on our own. Yep, don't even write this down. Let's go ahead and just graph it. Here we go. First graph. F of x equals 2 to the x, or 2 times x to the third, plus 5x squared minus x minus 6. And we were given that 1 is a 0. All right. So in order to graph this, I need to know all of the zeros. Now we could easily cheat and put this into our graphing calculator and see what it looks like and then just trace it. Okay, but we're not going to do that. We're going to actually do the math to figure it out. Because I'm given one of them being a 0, if 1 is a 0, then that means somewhere on my graph, one of my x-intercepts, oops, I'm in highlighter mode, is going to be 1. Well, since I have a degree of 3, I could have 3 possible zeros. Right now I only have 1. How do we find the other zeros? What did we do back in, we use synthetic division. What goes in my half box? Let's plug in 1. My coefficients are 2, 5, -1, -6. Let's go ahead and work it out. Bring down that 2. 1 times 2 is 2. 5 plus 2 is 7. 7, adding makes 6. 6, remainder of 0, perfect. So that means it is correct that it is a 0. Now I'm left with 2x squared plus 7x plus 6. Can we factor that? Yeah, factors of 12 that add up to 7, 4, and 3. Put them both over the leading coefficient, which is 2. What do those look like in factored form? 2x plus 3, and the other one would be x plus 2. This 0 of 1 would look like what in factored form? X minus 1, right? So here's my whole entire polynomial in factored form, which is great. So what are all your zeros? 1, we already got that. -3/2, so let's plot that. So -3/2 is -1.5. So eyeball where that would be. And then the third one would be what? Be -2. So those are pretty close to each other. Okay. So what's this going to look like? What's going to be the left behavior of this graph? Degree is odd or even. Odd. Leading coefficient, positive or negative? Positive. So what's happening on the left side? It's going to be falling down, right? What's going to be happening on the right side? It's going to be going up. So I'm just going to make a little arrow going like that and a little arrow going like that just to remind me that that's what the left and the right behavior should look like. But now I got to kind of figure out what's happening in here. So do you remember back when we did inequalities, we kind of made ranges or boundaries between each of these things to see what's happening in between? So I already know what's happening here, so I don't have to do -infinity to -2, right? Because we already know it's going down. So now let's go from -2 to -1. I got to figure out what's happening here. From -1 to 1. And I already know what's happening from 1 to +infinity. It's going up. So pick a tester point. What's a good tester point between -2 and -1? Right, so my tester is going to be f of negative 1.5. And there will be a good tester point between negative 1 and 1. 0. So a good tester here would be evaluating the function for 0. Let's do the 0 one first. That one's easier. If I plug in 0 up here, what am I going to get for my output? Negative 6. Good. So because I get a negative 6 at 0, what should be happening between negative 1 and 1? It should be going down and then somehow popping back up. Do I know it's popping back up at 0, negative 6? No, I'm not quite so sure about that. But I know I'm probably going to have something happening where it's going down and then coming back up. Now let's test negative 1.5. I'm going to cheat and use my calculator here. 2 times negative 1.5 to the third power plus 5 times negative 1.5 squared minus negative 1.5 minus 6. I end up getting 0.
Because it is a 0.
Oh, that's right. Because I didn't pick the right numbers. Thank you, Kevin. Like, that's crazy. Does everybody see what I did wrong? My range should be from negative 2 to negative 1.5, not negative 1. So we need a different tester point. 1.75? Sure, negative 1.75. Sorry about that. Okay, let's redo this then. 2 times negative 1.75 to the third plus 5 times negative 1.75 squared. I'm making sure I put parentheses around my negative 1.75 every time I take it to an exponent. Oops, and I didn't do something right. All right, is anybody getting 0.34375? Sure.
Sure.
What? When I typed it in my calculator, that's what I got. Is that a positive or a negative number? That's a positive. So would this graph be coming back down or going back up? It's going to be going up in the positive direction. So let's just put a little bump up there, like such. And then continue our graph down, continue our graph up. If we were to graph this, you could see what it would look like. Let me do it on Desmos really quickly and see how accurate we were. So, what is it? Is y equals 2x to the third plus 5x squared minus x minus 6. All right, let's see how well we did. Not too shabby. Okay. Was that turning point at negative 6? Yeah, it was. Were we sure about that? Well, I guess it's more. It's not quite 0.6. It's more at 0.095 negative 6. Okay, close enough. So there would be a good sketch of our graph. All right. So given a 0, use your synthetic division to come up with it in factored form, just like we did. And then figure out your left and your right behavior. What's happening on the left, what's happening on the right. And then pick your tester points in between and figure out where you're going to go. Okay, so for your homework, we have about 3 minutes left. You're going to be doing 25 through 45 every other odd, because that would be a whole lot of graphing. For, let me make sure, 29, 33, 37. So for 41 and 45, well, sorry, 41 and 45, they give you the 0 just like we did here. In 25, 29, 33, and 37, they give you all of them but I think 2 that are not in factored form, so you're going to have to try to get that into factored form. And you can either cheat or factor by grouping or something like that. Okay? Questions? All right, we'll continue 12.3 tomorrow. and go from there.